Have you ever looked up at the night sky and wondered how long it would take to travel to the moon, or even to distant planets like Mars, Jupiter, or Pluto? Today, I invite you to embark on a gentle and fascinating journey through space. But don't worry, this won't be a confusing science lesson. It's a moment just for you, to spark your imagination and bring back that childlike curiosity we all carry inside, no matter our age. You've lived through some of the greatest discoveries of our time, and now you'll understand how far we've come in exploring the universe and how close we might be to touching the stars. This is your time to wonder again. If you don't want to miss any valuable insights like this, especially those that make you feel inspired and informed, go ahead and click the subscribe button below. It helps the channel grow and ensures you'll always be the first to know when a new journey begins. And if you're enjoying this moment, leave a quick comment below with one powerful word that describes how the universe makes you feel. Don't forget to like and share this video with someone you care about, because beautiful discoveries are even better when shared. Stay with me until the end. There's a very special message waiting for you that I promise you won't want to miss. Shall we begin? Reaching the moon was once only a dream. For centuries, people gazed up at that bright distant sphere in the night sky, wondering what it was made of and what mysteries it held. That dream became reality in 1969 when the Apollo 11 mission made history. For the first time, human beings stepped onto another world. The distance between Earth and the moon is about 384,000 kilometers, and it took the astronauts just 3 days to get there. That might sound short, but the journey was anything but simple. Imagine traveling in a spacecraft, moving at nearly 40,000 kilometers per hour. That was the speed of the Apollo missions. It feels incredibly fast, yet in the vastness of space, it's like a gentle cruise. The mission required absolute precision. Even a small error in calculation could have led the astronauts far off course, or worse. That's why NASA's engineers and scientists worked with extreme care, checking every detail. There was no room for mistakes. What's truly amazing is that the computers used to guide those missions were far less powerful than the phone you might have in your pocket today. Still, with that limited technology, they achieved the impossible. That tells us something important. With determination and teamwork, even the most distant dreams can come true. When the astronauts finally reached the moon, they stepped into a world unlike anything we know. With no atmosphere, there was silence, total, profound silence. The horizon looked strange, curved in a way we don't see on Earth. Their footprints still remain there today, untouched by time or wind. It's a place frozen in history. But as incredible as that achievement was, the moon was just the beginning. If it took only 3 days to get there, how long would it take to visit the other planets, Mars, Jupiter, even Pluto? Each journey holds its own challenges, and as we continue exploring, we discover that space is not just about distance, it's about patience, strategy, and courage. And so, as we leave the moon behind, our next stop is the fascinating dance of the planets, the key to understanding how to move through the solar system. After leaving the moon behind, our journey takes a new direction, one that reveals just how complex and beautiful our solar system truly is. When we look up at the sky, the planets may seem to move in neat, predictable paths, but the reality is far more fascinating. Each planet follows an orbit around the sun, not in perfect circles, but in stretched ovals called ellipses. This small detail changes everything. You see, as planets travel around the sun, their speed isn't always the same. When they're closer to the sun, they move faster. When they're farther away, they slow down. This rhythm, described by the laws of Johannes Kepler, shapes not only how long a planet takes to complete a full turn around the sun, but also how we plan our space missions. If we don't take this into account, a spaceship could miss its target by millions of kilometers. It's like a cosmic dance, with each planet moving to its own unique rhythm. Earth takes 365 days to complete one orbit, but Mercury, which is much closer to the Sun, zips around in just 88 days. On the other hand, Neptune, the distant blue giant, needs a full 165 Earth years to finish one orbit. That means if you were born there, you wouldn't celebrate your first birthday until you were an old adult here on Earth. Every planet marks time differently, and understanding these rhythms is essential for reaching them. If we want to send a spacecraft to another planet, we have to wait for just the right moment, when both Earth and that planet are in the perfect positions. Space doesn't offer shortcuts. One wrong move, and we could be chasing a moving target across the solar system. This invisible choreography guides our every step in space. It teaches us that timing is everything. Before we even leave Earth's orbit, we must respect the delicate balance of the cosmos. Now that we understand how planets move, we can explore how scientists use this knowledge to travel between worlds, saving fuel, time, and making the impossible possible. Now that we understand the graceful motion of the planets, it's time to talk about how we move between them. In space, traveling isn't just a matter of pointing a rocket in the right direction and going full speed ahead. Everything out there is in motion. The planets are moving, the spacecraft is moving, and time is always running. That's why scientists need to be not just bold, but smart. One of the most efficient ways to travel between planets is called the Hohmann transfer. Think of it like changing lanes on a highway, but without slamming the accelerator. The idea is to move from one orbit to another using the least amount of energy possible. The spaceship gives one push to leave its original orbit and another to settle into the new one, just two key maneuvers. But for this to work, the timing has to be perfect. The destination planet must be in just the right place at just the right time. To make this easier to understand, imagine you're on a road and you want to switch lanes. Instead of speeding up and swerving, you wait for a perfect opening and glide over smoothly. That's what a Hohmann transfer does. It's not the fastest method, but it's incredibly efficient. That's why it's used in most missions to Mars, Jupiter, and other planets. But there's another trick scientists use, and it's even more clever. It's called gravitational assist, or slingshot maneuver. In simple terms, the spacecraft uses the gravity of a planet to pick up speed, like being pulled in and flung forward. This way, we can travel farther without using extra fuel. And the planet doesn't even notice, because its mass is so huge compared to the little spacecraft. A great example of this was the Voyager missions. Those tiny spacecraft used the gravity of Jupiter and Saturn to slingshot themselves out of the solar system. Without that assist, they'd never have made it so far. These techniques show that space travel is not just about power, it's about precision. In a place where resources are limited and distances are vast, saving every drop of fuel can mean the difference between success and failure. Now that we've learned how to travel wisely, let's look at what it really takes to reach our planetary neighbors, and why each destination brings a new kind of challenge. With all the strategy and precision behind space travel, you might think getting to the closest planets would be simple. But even the neighbors of Earth come with enormous challenges. Let's begin with Mercury, the closest planet to the Sun. It might seem like an easy destination, just 58 million kilometers from Earth. Yet reaching it is one of the most difficult tasks in spaceflight. Why? Because of the Sun's gravity. As a spacecraft approaches Mercury, it's pulled toward the Sun at great speed. To actually reach and stay in orbit around Mercury, the spacecraft must slow down gradually over time. That's not easy when the Sun is constantly trying to speed it up. The Bepi-Colombo mission, launched in 2018, had to plan 7 gravity-assist flybys before it could finally enter Mercury's orbit, arriving only in 2025. That's 7 years of planning and patience. Then we have Venus, our closest planetary neighbor in terms of distance. It's only 40 million kilometers away, and a spacecraft could reach it in about 6 months. But arriving is just the beginning of the problem. Venus is one of the most hostile places in the solar system. Its thick atmosphere is made mostly of carbon dioxide, with clouds of sulfuric acid, and the surface pressure is 90 times stronger than Earth's. Imagine standing a kilometer underwater. That's the kind of pressure Venus exerts. And the temperature? Hot enough to melt lead, around 470 degrees Celsius. Most spacecraft sent there have been crushed or melted within minutes. The Soviet probe Venera 13 survived just 127 minutes, and yet we're still drawn to Venus. Some scientists believe it was once similar to Earth, with oceans and a mild climate. What caused it to change so drastically? Could it be a warning for us? Then there's Mars, the planet that has captured our imagination for decades. About 228 million kilometers away, Mars can be reached in roughly 10 months. But the hard part is landing. Mars has a very thin atmosphere, not enough to slow down a spacecraft with parachutes alone. That's why the Perseverance rover used a heat shield, a supersonic parachute, and a jet-powered sky crane, all just to land safely. Each planet brings its own set of trials, but also promises of discovery. And as we set our sights beyond Mars, the challenges grow even greater, and so do the wonders. After the dusty deserts of Mars, our journey leads us to the true giants of the solar system, Jupiter and Saturn. These two colossal planets are not only breathtaking in size and beauty, but also bring some of the greatest challenges and discoveries we've ever faced in space exploration. Let's begin with Jupiter. Sitting nearly 780 million kilometers from Earth, reaching this gas giant takes about 3 years. It's a long trip, long enough to make an astronaut question every life decision. But arriving is only part of the adventure. Jupiter doesn't have a solid surface. Any spacecraft that tries to descend into its thick atmosphere would be crushed long before reaching anything solid. The pressure and temperature increase so quickly that no known technology could survive the descent. And yet, Jupiter plays a critical role in our solar system. Its immense gravity acts like a cosmic shield, pulling in or deflecting dangerous asteroids that might otherwise head toward Earth. It's also home to the largest magnetic field among the planets and hosts enormous storms, including the famous Great Red Spot, a swirling tempest that's been raging for centuries, large enough to swallow 2 Earths whole. But the real treasure might be Jupiter's moons. One of them, Europa, has a thick shell of ice that could be hiding a vast ocean underneath. And where there's water, there may be life. The idea that something could be swimming in the dark seas of a distant moon is nothing short of thrilling. Then comes Saturn, the crown jewel of the solar system. It's located about 1.4 billion kilometers from Earth, and any journey there takes at least 4 years. Saturn is most famous for its rings, huge shimmering bands made of ice and dust, stretching wide but incredibly thin. They look solid, but are actually made up of countless fragments, some no bigger than grains of sand. Like Jupiter, Saturn is a gas giant, and its surface is unreachable, but its moons are fascinating worlds of their own. Some may have underground oceans or even geysers that spray water into space. Exploring these distant giants is difficult and time-consuming, but they remind us just how vast and varied our solar system truly is. And still, there's more waiting for us in the cold beyond. Now we reach the edge of our solar system, a place where sunlight fades and time seems to slow down. Here, far beyond Saturn, lie the distant and mysterious worlds of Uranus, Neptune, and Pluto. These frozen giants, though less visited, hold secrets that could change everything we know about space. First, there's Uranus, located about 2.9 billion kilometers from Earth. A trip there would take nearly 10 years, but what makes Uranus so unique is the way it spins, completely on its side. No other planet in the solar system rotates like that. Because of this, its poles experience 42 years of darkness, followed by 42 years of sunlight. Its atmosphere, filled with hydrogen, helium, and methane, gives it a blue-green glow. It's also the coldest planet we know, with temperatures dropping to -224 degrees Celsius. But beneath that calm appearance, its winds can reach over 900 kilometers per hour, faster than any hurricane on Earth. Then comes Neptune, the most distant of the known planets, sitting 4.3 billion kilometers away. A spacecraft would need at least 20 years to arrive. Neptune is a deep blue giant with wild storms and the strongest winds in the solar system, over 2,000 kilometers per hour. It also has faint rings and a fascinating moon called Triton, which moves in the opposite direction of Neptune's rotation. That alone tells us Triton may have come from another part of space. Even more intriguing are the geysers on its surface, which spray frozen nitrogen into the sky, proof that there is still active geology in this far-off world. And finally, we come to Pluto, once considered the 9th planet. Though now called a dwarf planet, it has never stopped capturing our imagination. Located up to 7.4 billion kilometers from Earth, it took the New Horizons probe 9 years to reach it. When it finally arrived, we were amazed. Mountains of ice, frozen plains, and even a heart-shaped region welcomed us. Its main moon, Charon, is so large in comparison that they orbit together like dance partners. These distant worlds remind us how vast the universe truly is. And even at the edge of the solar system, we find beauty, mystery, and the promise of more discoveries to come. Now let's reflect on what this journey through space means for us, and what comes next.